Hi everyone, I'm Jake, and I'm going to introduce you to the Mimic Pro, a VR body system for Unreal Engine. First thing we're going to start with is calibration, as always. And as the player, you can calibrate either seated or standing. And as the developer, you have the choice for standing calibration to either scale the mesh to match the player's height in the real world, or you can scale the player's play space to match the mesh's height in game. You also want to calibrate with your arms outstretched in front of you because it's going to estimate the player's arm length and scale the character's arm length to match that. As you can see, I'm a little bit taller than the mannequin, so when I stand up straight, the legs stretch. And when I put my arms out in front of me, the mannequin's arms straighten really early and then continue to stretch as I reach out. And that doesn't feel very natural. So I'm going to go ahead and calibrate. And as you can see, the legs no longer stretch when I stand up straight, and the arms have to stretch a lot less to reach that outstretched position while still looking natural. All that calibration data is saved and reapplied whenever the system is loaded, meaning that calibration is persistent between levels, editor sessions, and your player's game sessions. Over here, you can see the system is compatible with the Unreal Engine 4 and 5 standard skeletons. I'm going to go ahead and switch to the Unreal Engine 4 mannequin. As you can see, it works just as expected. And I have two identical skeletal meshes here. One is rigged to the Unreal Engine 4 skeleton, and one is rigged to the Unreal Engine 5 skeleton. And you can see that both twist bone solutions work well. Now you have per skeletal mesh settings as well. So, these two both use the Unreal Engine 4 skeleton and they use the same animation blueprint, but I've changed the settings for this skeletal mesh so that it does not use twist bones because, it's a hard body with ball joints. It wouldn't feel natural if it did, but we can switch to this one and it will use them. Now, all of these are soft references, so, the different animation blueprints, different skeletons, and skeletal meshes in the system are all loaded asynchronously, so you don't have to have them all loaded into memory at the same time to use them. I've got a character and a pawn integration example. The system is modular. It's all controlled from one component. So you can add it to any existing VR character or pawn that you might be using. And I've also included examples that show how to integrate with a lot of things you might want. For example, like foot IK conforming to the ground. There's, capsule collision. So if I try to walk through this wall in my room scale, in my physical space, I can't. And if I try to go under it, I can't slip under it until my head is low enough. And there's also like joystick crouching and, wall collision. So players can't peek through walls. I've also got an example of a moving platform. So when I stand on this, my leg animation transitions into, local space calculations for the direction and speed. So, I'm standing still on this platform and I can walk on it. And as soon as I step off, it goes back to world space movement. You can change the scale of the player in versions newer than 5.1, and it will scale like your in-game IPD appropriately. So your perceived scale works. You feel like a giant, or you can go really small. And all of this is network replicated. My near clipping plane needs adjusted, but other than that, it all works beautifully. The HMD and controller transforms are quantized and network replicated with controllable frequency. Finger animations are replicated, joystick crouching, skeletal mesh switching, and calibration It's all seamlessly replicated. So thank you for watching. I'll leave a link to the product page in the description where you can find a downloadable demo, documentation, tutorial videos, all the features, and my contact information if you have any questions or concerns or need support after purchasing the product. So thank you. Bye.